All right. Well, hello everyone, and welcome to Real-Time Java and AI. Welcome, Mary and Cedric.
Hello,
Yeah,
Aaron.
thank you.
Happy to be here, as
Hello,
usual.
hello. Yes, yeah. Very cool. Yeah. So I think for us, this will be like, well, kind of we can say it's the last episode of the current season.
Hmm.
But we're gonna
Hmm.
be, we will prepare for you some to show you some of the example. One is Aaron will be showing the clip uh, app that you did at the workshop 2 weeks ago, and then if there's time, I show a quick LangStream enabled chatbot too. So yeah, and then we be just chatting, yeah, and today. So yeah, thank you, and yeah. So shall we then start with Aaron?
Yeah,
I think
I
we
think that's a
we should
great
let you go. You
idea.
promised us
Yeah.
some demo a couple of weeks ago, I guess.
Oh.
Here we go. We can see your screen now.
Hey,
Got it.
outstanding.
Yep, I can see.
So anyway, if you've looked around on our site and looked through like some maybe like the quick start examples that we have, there's this one. It's called image search with clip. Clip, of course, being the contrastive language image pre-training model. And the idea here is that you can create vector embeddings using just an image. And if you walk through the example, we actually have a Google Colab notebook here that we'll bring it up, and it'll show you like kind of how to walk through each of these steps in Python, and actually kind of it takes you through building out your schema. Yeah, here we go. There's the creating the table, creating the storage attached index on it, and then running it through. And then you can go ahead and search. So this default search is a house with a swimming pool. And when you run it, if you did it right, it comes up with, a house with a swimming pool, of course. Right. So, of course, as I'm going through this, I'm thinking to myself, hey, how could we do this in Java? Wouldn't this be super cool to do something like this in Java? I started out using LangChain 4J, which is not an official LangChain project, but still pretty cool and allows you to work with, a lot of the typical like modular LangChain components from Java, of course. I did have a little bit of an issue getting images to embed properly, because right now LangChain for J for creating embeddings takes a string, and of course, an image is a binary type of an object. So I still have the data loaded with the Python side, but I thought it'd be pretty cool to put like a build like a Java application that kind of takes on that prompting measure and allows you to like do a little bit of like searching based on the images. So if you look at a lot of the images in the example, it's essentially images of houses. So you could go ahead and then search on those houses based on, and it would bring up whichever one kind of matches the closest. So my implementation of this, I actually did use Spring Boot Spring Data on the back end. So here we have custom query comes into play, where it'll do a order by ANN on the item vector column. So this is actually doing the vector search here. For the controller, here's the service that's being exposed. But yeah, simply put, it just it takes the vector provided and calls that find images by vector repository method or custom repository method, returns a vector image as a list, even though there will only be one, but that's okay. That gets shown inside the the Vaadin front end here. This is going to make a call out to Hugging Face, and it's going to use that clip VitB32 large language model. If I go ahead and I run this, and of course it has all of my AsterDB credentials kind of already in the run configuration.
Yeah,
Waiting for
so
Cédrick.
Aaron, here you are doing the vector search by hand, kind of, not
Kind of,
using
yeah.
any LangChain or G-Llama type of framework. You just build the embedding yourself and do the search with the Cassandra query, right?
That's right. That's
Okay,
right.
nice.
Yeah, it's so it still uses Hugging Face and that particular clip model because it'll take the sentence you type in and create an embedding from that that should,
Yeah.
I'll allow you to match up with
Oh, you're right. You still need to have a vector to do a vector search. So
exactly.
there are not so many models out there that work with images, and even less doing multimodal. So now, starting this month, we have a few models that can do both text and images at the same time.
Oh,
Like
right.
the embeddings on the same vector space with both text and images. But yeah, it's not very it's not very used as of today.
Yeah.
That's true. All right.
Yeah.
So hey, according to what I'm seeing here, this is running. So
Yeah,
with any
it's
luck,
like
if I bring up localhost 8080. All right. So this is kind of the interface. So the idea too was that I'm actually using a Vaadin drag and drop component here. So if I could get the image embedding to work right, this would be the way that you could do it, is just kind of like drag an image in here and then you'd be able to search on it right away, but not working just yet. But the real magic here is that if I go up to my query bar here and I say house with a pool, and then I run that query. Oh, look at that!
Very cool.
And I can change this up a little too. It's nearing Halloween, so I can say house with pumpkins, and if I run that query, oh, look at that! You can.
Okay.
You know what I can do?
Yeah.
I can increase the size of all this too. Let's see. I think there's also a pink house in there. Yeah, so if I run that, oh, yep. See?
Oh, wow.
nice. So it's working. Yeah, nice.
And this is like a mini house actually, but and then I could say house on a lake.
Okay, so again, what is the data set you used to populate your database?
Yeah.
So the data set. This is the Python code where it actually loads and generates those embeddings. So the houses are really just named 1, 2, 3, 4, 5, and then of course there's pink house in there.
Okay.
I also at one point had blue house and yellow house, but those actually caused more problems than they helped. So I got them out of there. But this is where the model's doing an encode, and then it kind of creates the data as an array, and then here's where it writes it into AstraDB.
Okay.
So that's really how the data set is processed and loaded. If I went over to here, I mean, you can just kind of see that this is the the table with the 6 houses in it.
Okay.
If I modified this a little bit and just said select star, you would see the embeddings. Yep, that are with it as well. But I could do like a describe table images, and you can see that that vector column is a float 512 to match up with the clip model that we're using there. And then of course there's our our storage attached index here as well.
Yeah. So what was the problem then? You mentioned about, I'm sorry.
Oh, that's okay.
Yeah, you mentioned about like some greenhouse, yellow house having trouble loading. Is that because of certain, issue? I'm just curious.
So when I had the blue and yellow house in there, for some reason it was pulling those houses up with some of these other images. So I think maybe the it just maybe it would take like some additional training to to maybe fine tune it a little bit. But oh, and by the way too, this is my my cabin on Lake Minnewawa in northern Minnesota. I actually took this picture. So. But yeah, when I had those
very
houses
nice.
in there, for some reason, like house on a lake would bring up the blue house, so it
Okay.
was, yeah,
Oh,
it was doing things like that. But
the-
hallucinations, right?
oh yeah, that's right. Yeah, cool.
Let's see. I think I could say like White House.
So it's actually the clip model that will find out what is in your image and encode everything maybe as text. And when you enter text, it's like, oh, this is what I've been recognized by clip model when I inserted things. Because I don't see any metadata in your table. It's all coming from the image.
It's all the image. That's right. That's right.
Oh,
Oh yeah, there we go.
okay.
Well, maybe the roof of this one is white, but that's how.
Okay. Oh, cool. Yeah.
Yeah. Oh,
That's cool.
but yeah, you're right. Here you go. It's like you can see that for the encoding, it's just using that JPEG image of each house. So yeah. Yeah.
Question, maybe not 100% related, but where do you store your images? When it's retrieved that image, where it's coming from?
Oh yeah. So I actually have an images directory that's behind
Okay.
all of this.
All right. So it's like image src blah blah blah. You just put. I'm with you. You do not want to have the binary of your files in the Cassandra database. That does not make sense. You would rather use S3, in the cloud S3 or object storage model, file system ish. Actually, you even have some open source tool out there doing some file system on top of S3 with the metadata in Cassandra for you.
Okay.
Oh.
Okay.
Very cool.
But yeah, so that's actually if I go back a couple of queries here. So when the vector embedding pulls a row back, that's where the app is taking, whatever's coming back in the name and then loading that. Let's see here. Oh yeah, here we go. So yeah, this is where it prefaces the image file name on load with the images / directory, so it knows how to create that file stream and pull it in. So
No, but that's still an interesting topic, because how do you keep in sync your vector space and your data set? You can think having all of them in the same Cassandra database, and if you change one, you also change the other, even if that's not the ideal world where you have your file system. But still, that would have a single source to get the data and the vector space, and that stuff can scale. So, I was thinking maybe why not, right?
Could be.
Like, was because I start thinking about that use case. All our vector, all the vector from the single image could be in the single partition. You put as the partition key the file name. You put actually the binary data as a static column blob, and then all of a sudden you have one partition per document, and you can totally do vector search, update, and then do everything in a single table. So that's some avenues we could investigate in the future.
Yeah, Cédrick, that brings up a good point about providing like a partition key in the where clause when you're doing something like this. The use case that I think of with something like this is like Zillow or Realtor.com, or where you can say, hey, show me a house with like 3 bedrooms and it's on a lake, and things like that. But you'd limit it by like whatever geographic area that you're in. So so the geolocation maybe could be like the partition, and then you could run the image search inside of that, with the vector embeddings. But yeah, I mean, yeah, something like that could work.
Sure.
Well, and that's great to see that embeddings can be computed not only on text but also on images.
Oh yeah.
Right. Right.
Yeah, right. And so you were about to share the link of the repo.
Oh yeah.
That's right.
All right.
There we go.
Image search in your. Oh, okay. You put that as a banner. That's great.
Yeah, that's
Yep.
good.
Yep.
This is like from our data stacks, our documentation, right? One of the examples too,
Right. This is there we have a few of these out there. Another one is building out like a simple chat bot. And yeah, this one is image search. So this is the one that Patrick and I did in our workshop in San Francisco a few weeks ago. That everyone thought that was pretty cool. Actually, it really did get people talking. So
cool, very cool. Yeah.
All right.
Awesome.
Well, that is all I have.
Yeah. So
Okay.
Maybe for me, I'll just quickly kind of introduce the audience to LangStream. I don't think it's being talked on this series yet, right? On this podcast. So let me share
do it,
my
especially
screen.
because it's done in Java. So
yeah, that's right. Yeah. Let me get my window. Okay. So maybe just really quickly to again, don't have as much time getting into deeply, but wanting to introduce to the audience about LangStream, which is an open source library that one of our engineering teams have been working on, and this one is essentially leveraging on event streaming for generative AI type of application, and is very kind of built, with the idea that, you don't need to worry about writing as much code. And basically, too, is essentially, kind of if you look into event streaming really quickly, we're enabling you to build data pipelines. And in this case is that we have different connectors as well. And we have also what is called like agents too. So agents, we also have pre-configured agents, and some of the more, typical jobs that you would be working, you can use some of these pre-built type of agent to do your work. But if you want to customize your own agent as well, you can do it. And as you can see over here, this is the project right on our GitHub and the README. And so as you can see, we kind of allow you to have data ingestion part, and currently it's mostly working with Kafka, but we also support Pulsar. But the thing is, with Kafka is that it because it's more commonly used, so that's the design decision too. We decide to use kind of more of Kafka side, and we also have our runtime as well. So that's kind of like a quick kind of overview, right? Without getting all the details, and I know folks wants to do it, but I also have my Twitch stream, so maybe at some point let me get into there and do more kind of detail, example of it. But for now, I just thought will be good is to quickly take a look into this particular example, and I'll also quickly show you too. So this is what I'm running too, running the this particular LangStream, because it has its own runtime too. So, and also I'm relying on Docker. So in order to run this, you do need Java and also Docker. Yeah, and in order to do it, and of course you want to install your LangStream too. So there's also a page that actually show you too. So this is the LangStream.ai that folks can go to. And again, right, it will kind of show you the different connectors that we have in here, and it's very flexible, designed to be very flexible. It works with different databases like actually our Astra right now, and Milvus, and then it works with LangChain, Llama Index, all of these. So very kind of convenient in that sense. And also there's a Visual Studio Code extension too, if you kind of want to work with it. So yeah, I hope to kind of add to like JetBrains, maybe some IntelliJ or something. But anyway, so just for now, having a short time, just kind of show that example. So if you go to the Get Started page, and this is what it shows you. First, you install LangStream, which I've already done it. And then you also want to get an OpenAI access key for this particular example. And then quickly, too, is actually, as you can see, just to quickly bring this up is not many steps at all. And basically, LangStream and Docker running your container. In my case, I'm using the local, so it is already running. And so it will pop up, and then let's see, because now is Halloween, right? So let's kind of, this is write a Halloween poem, something. Let's see if it can do it. Yeah. I think I tried once actually. That came out pretty funny too. But let's see. I actually asked it to do a Halloween parody. Here we go. In the dark of night, when the when the moon is high, ghosts and begin to fly. Bats flutter and owls hoot. As Halloween arrives, resolute. Creatures awaken from their slumber. Haunted houses start to slumber. With creaking doors and eerie sounds, they fill the night all around. This is funny. So anyway, I won't kind of read them all in here, but as you can see, I think this is something fun to do. You can kind of ask it to do a different thing as well. But again, this is just to quickly show you the audience too that this event streaming kind of combining best of both worlds with this and also a Gen AI type of application, building your chatbot. So yeah, okay. All right.
We can tell you are using streaming up to the onto everything, even streaming events were coming from GPT.
Yeah, that's right. Yeah, I like using streaming. It's actually for me too. I got into working with First Cell, right? And it's kind of it became so new to me 2 days ago, right? I was just told work with First Cell, and so I'm like, what is First Cell? That's also streaming, but it's making React. It's very JavaScript. Not sure if you folks have used it, but I'm like, oh, it is interesting. Let me dig more into it, and it's kind of this.
Yeah, so you are starting your next JS journey, I think, because Next.js is like React done by Vercel. Great stuff.
Right. It seems very cool in terms of able to render things, on the fly. And so, yeah, that's pretty cool. So that's something maybe I'll do it on my own Twitch stream. So yeah, doing experiment. So yeah, okay, awesome. Yeah.
Well, it was yet another great week with great demo. Hope you share the link as well of LangStream below the live.
That's right. I should do it too. Yes.
The last episode of the first season, but we will come back soon for another season. And actually, we need your feedback. What can we do to improve? What do you need to see with us on screen? Comment the format. Is it long enough, deep enough? What kind of asset do you want to build? All the feedback is good. Yeah, please comment below and we will come back stronger with what you ask.
That's right.
Yeah, that's right.
Thank you. Yeah. Thank you. Yeah.
Awesome. Yeah, and this has been really great. I've really enjoyed this little project and putting this series together and getting to work with Mary and Cédrick as well is always pretty cool too. So yeah. So thank you both. I've enjoyed this.
That's right.
Yeah, and see you all very soon on all kind of meetups as well.
That's right. Okay. Well, thanks everyone. Goodbye. And
got it right.
We'll see you all.
Thank you.
Bye, everyone.
Yeah. Okay. Great. Thank you. Thank you so much. Yeah. Maybe when I do my Twitch, let me get you guys onto my Twitch too. I think it's easier than.
That'd be awesome.
It's just it'd be easy too. Yeah. Okay. Awesome. Thank you. Yeah. All right.
All right.
Bye.
Bye.
Bye. Bye.